All right, I would now like to introduce you all to Fred Kraybill, an advocate for renewable energy, electric vehicles, and climate action with the Thomas Blvd Group. He will be presenting on the electric vehicle revolution.
Hello. Okay, there's a lot of people out there with electric cars, so if I make a misstatement, you correct me, okay? But anyway, I'm a big advocate for electric vehicles, big fan of electric vehicles. And I've worked with the Solar Fest in Pittsburgh in the past. We also always have an electric car show at the Solar Fest, and I've worked with them in the past. But I'm a big follower of this industry, and I'd like to share with you some of the good news that I think is good news. I think we're transitioning to electric vehicles worldwide. And I'd just like to start with some of the global trends that we see happening in electric vehicles today. So this is articles from a website called Clean Technica. Jose Pontes compiles worldwide data on electric vehicle sales. In August of 2023, the world EV market hit 18% of all cars sold. 18% of them had either a plug-in hybrid or a full battery electric vehicle. Now, some of you might be saying, I don't see that in my community. Where is that happening at? What is really quite amazing is China is leading the world in electric vehicles right now. Right now, about 40% of the cars sold in China are electric, either plug-in hybrids or fully electric. In Europe, that's about 22%. In the US, it's about 6.5%. And California is really leading the US in electric vehicles. In Q1 of this year, electric vehicle sales in California hit 20% of the market, and 1 quarter later in Q2, it hit 25% of the market. So the total sales of worldwide sales of plug-in vehicles for August of 2023 was 1,200,000. If you extrapolate that out, that's going to be about 15 million electric vehicles sold worldwide in 1 year's time. So this chart right here from the same article is the top 20 electric vehicles sold worldwide. And what you'll notice about this chart is, again, China is really leading the world in electric vehicles, but everywhere, this revolution is accelerating. And so on this chart, you're going to see the Tesla Model Y, the Tesla Model 3, and most of the rest of the cars are electric vehicles that are made by Chinese manufacturers. And then a few other ones in there are 2 VW models, a Volvo model, and a Hyundai model. But the legacy automakers, the European automakers, the Japanese automakers, and the US automakers, they're starting to catch up now. But this just really highlights how much this is a phenomenon that China is really leading on. And another interesting thing is that does anybody know what the #1 selling car in the world was last year? And I think it's been quite a number of years in a row. Does anybody want to guess what that car is? That would be #3 last year. I'm talking in the world. I think that would be the leader in the US, correct? But in the world, the F-150 or the Ford F-Series are #3. So what is the #1 and 2 car in sales last year? Toyota Corolla and Toyota RAV4. This year, we are on track to see possibly the Tesla Model Y be the #1 selling car in the world. Not just electric car, but #1 car, period. So I just want to reminisce it back to when in 2012, I bought my Chevy Volt. And I remember going to the dealership and, it was the first time electric cars had appeared in Pittsburgh. It was going to be either the Volt or the Nissan Leaf. And Nissan Leaf was delayed because of the tsunami in Japan. So my choice was easy. I got the Chevy Volt. I remember the people in the dealership kind of looking at me and almost felt like they were saying, are you really going to buy this car? And here we are 10 years later, electric cars are really making mainstream. And I believe they have quite a lot of advantages over the gasoline car too. So this is the last one I'll do about the global trends in electric cars. You can see we're starting to hit this spot where it's a disruptive technology and it's really starting to catch on and accelerate quite a bit. So 2018, 2 billion electric cars sold worldwide. 4 years later in 2022, 10.5 million. And the estimates for this year, I think we could get close to 15 million electric vehicles sold worldwide in 2023. So we covered the global trends. Now let's talk about some of the advantages of electric vehicles. Basically, electric vehicles are cheaper to fuel. They require less maintenance. They're safer to drive. They have better performance and acceleration than gas cars. And as the charging improves for electric vehicles, and as they continue to come down in sticker price, I think we'll find that most consumers will choose electric vehicles as they learn more and more about them. I'll concentrate on the first two here. The cheaper to fuel is just a simple number. You can figure out kilowatt hours and how much mileage you get on a battery and what it compares to cost per mile on a gas car. But think about the maintenance for a little bit on an electric car. The parts that you will never replace in a battery electric vehicle are the muffler, the catalytic converter, the muffler pipes, spark plugs, oil filter, engine oil, radiator, water pump, radiator hoses, transmission, air filter, etc. All these things do not exist on an electric car. And there's basically a lot less maintenance you'll find. So for full disclosure, though, I will tell you this: electric cars, the tires wear out a lot quicker than a gas car. So that's one thing to keep in mind. And then, but however, the brakes do last a lot longer on electric vehicles because of regenerative braking, which means the electric motor slows the car down as it's generating electricity when you're coasting or when you're braking. So, and then lastly, when you mostly charge at home, your EV fuel costs will be a lot less than a gas-powered car. So continuing on with advantages of electric vehicles are generally safer to drive. With the heavy batteries at the bottom of the car, it means that the EV has a very low center of gravity, and it's really difficult for electric car to get out of control and have a rollover event. Not nearly so on these high SUVs, gas cars that have a higher center of gravity. And we find that the traffic accidents, that a lot of the deaths that occur in a traffic accident is when the car rolls over. The car experiences a rollover. So electric cars are very difficult to roll over. The instant torque provided in an electric car, and I will show you a quick video of this at the end, they can accelerate a lot faster from a dead start than a gas car. And if you've never seen it, it's quite amazing. Like in a Tesla or some of these other cars, it has head snapping acceleration. So you can respond quicker to get out of an accident situation in an electric car. And also the heavier weight of the electric vehicle means that passengers are better protected in the event of collision. So I think of like a football game. You have two linemen, a 200-pound lineman and a 300-pound lineman. Well, obviously, the 300-pound lineman has quite an advantage in that situation. So similar with cars. And then last of all, there's other things that I could add to this, but I'll just highlight this last one. In a lot of your electric cars, they have the trunk area of the car does not have an engine. The electric motor is on the axle. So consequently, the front trunk of your car, also referred to as the frunk, has an empty space in it, and that frunk in a front end collision is like a huge shock absorber. It protects you a lot better than a car with a gas motor in it. Okay, and then the other advantages of the electric car. At the end, I'll show you a quick video of the acceleration of an electric car. And if we have time, I would like to cover some of the myths about electric cars, surrounding batteries and some of the other things we hear, sort of what's referred to as FUD about electric cars. You know what FUD is? Fear, uncertainty, and doubt. That's what FUD is about electric cars. There's a lot of it out there. They're new. A lot of people don't know about them. So I like to try to push back against the FUD sometimes. Okay, so the last thing I'm going to cover, and this isn't very comprehensive, the Inflation Reduction Act is out there. You also all should research the great benefits of the Inflation Reduction Act to the consumer. But the biggest one in the electric car space is the tax credit for brand new electric cars. It's a $7,500 tax credit, and it's a huge incentive to help people buy electric cars. What's going to happen on January 1, 2024 is the federal government's going to make that even easier to get an electric car. You won't have to wait till tax time to claim the $7,500 tax credit. You'll be able to take that money right off at the dealer, and the dealer will apply to the IRS claiming the tax credit, and they're supposed to be reimbursed within 72 hours. And the purpose of this is just to make the tax credit much more available. You don't have to wait months and months and months till you do your taxes to get that. So that's what you have at the federal level for EVs. You also have, if you install an EV charger at your house, I believe you can get like a 30% tax credit, up to $1,000 expense. And there's a bunch of other things in the Inflation Reduction Act related to you buy an electric oven, if you buy and get electric heating. And I think they even include on that if you have to change your circuit breaker panel as a result of upgrading your electric for some electric device. I think that's also in the IRA. I would check that one though. That's you can research that one easily. And the last incentive I'll talk about is that the state of Pennsylvania has a rebate for electric vehicles sold in the state of Pennsylvania. And it currently has money in that account for that. The rebate is $2,000 rebate for people who have an income level of 400% of the poverty level or lower, below 400% of the poverty level. There's an additional 1,000 if your income is 200% or below the poverty level. And but now something like this, there's certain criteria with that. If you want to access that state rebate, I would advise that you go to the Department of Environmental Protection and check out the criteria that's there. I also have an email ready to go. If anybody gives me your email address, I can send you a link to I can send you an email with the links for a lot of these articles that I pointed out here. The final thing I'm going to cover before we get into this fast accelerating car is, what about charging for electric vehicles? There's a concern out there that there's different kinds of charging plugs. Okay, there's the CCS system. Tesla has its own system. One of the problems is that 60 to 70% of the electric cars sold in the US over the last 3 years has been a Tesla. Tesla really is the leader in this space right now. So you have two different types of plugs at least out there right now. Well, I think the good news is that Tesla is overwhelmingly seeming to own this space. They have chargers everywhere. They have superior chargers. A lot of locations will have that are non-Tesla superchargers, have two chargers. One is broke down, the other one's being used, but Tesla at their locations, they have like a minimum of 8 stalls. So a lot of the car manufacturers have really kind of conceded that, yes, Tesla has built the best charging system. They have 50,000 superchargers worldwide, 12,000 superchargers in the United States. So this year, Ford has made a deal with Tesla to link their cars will be able to charge at this Tesla superchargers. That will start in 2024 with a simple adapter to the Tesla supercharger. You put the adapter on, it will go into your Ford electric vehicle. In 2024, Ford is going to change the actual architecture of the charging wiring in the vehicle to exactly match with the Tesla. They're adopting the Tesla charging system. Ford started this off this year, and now there are a total of 11 electric vehicle manufacturers that are going to adopt the Tesla system. And this is probably a good thing. It's not for sure, but it looks like most likely what's called the NACS Tesla system will be adopted by most car manufacturers in North America. That'll be North America. So the companies that includes are Aptera, Ford, General Motors, Honda, Rivian, Polestar, Volvo, Fisker, Mercedes-Benz, And recently, Hyundai and Kia have joined that list. So I think that's good. We're going to have a standardized plug for everybody. So finally, I'm going to do about 2 minutes of this video that just shows you the head snapping acceleration of electric car. How many of you people out there with electric vehicles know what I'm talking about? You know what I'm talking about? Yeah, okay. So we're going to look at the acceleration of a Tesla here. Do about 2 minutes of this and then try to make some time for question and answer. I don't know what time it is. How close are we to 2 o'clock? What time? 5 minutes? 9. Okay, thanks. The best way you can tell is by the reaction of the face of the person in the car. And this real video really doesn't do it justice. You have to be in an electric car to really appreciate the acceleration, I think.
Let's see.
Okay. Around myths about electric cars, you know, there was a lot of worry about the battery materials of the electric car. You know, lithium, cobalt sometimes referred to as a conflict metal. It's a lot of it's produced in the Congo with child labor conditions. You know, but it seems like the electric car industry gets a bad rap about cobalt. But the thing is, remember, we've been using cobalt for years. The oil refining industry actually uses a lot of cobalt. There's cobalt in your cell phone. And now some of the electric cars are going to a particular battery chemistry that eliminates cobalt, eliminates nickel, 2 of the metals that are in kind of short supply and are subject to price spikes. So that battery is called the lithium iron phosphate battery. And that one totally eliminates nickel and cobalt. So the point I'm trying to make is you hear a lot of criticism of electric cars related to battery metals. There's still a number of different metal ways to build a battery out there. There's constant improvements and technology improvements related to batteries. So we aren't really totally locked into one type of battery. And in the case of the lithium iron phosphate battery, those materials are all readily available. You know, you don't run into situations where it's subject to high price costs or something like that. The other thing is, what about battery recycling? So there's a gentleman by the name of J.B. Straubel. He was one of the early founders of Tesla, and he has recently started a new business called Redwood Materials. And according to Redwood Materials, they're saying that 95% of the battery can be recycled. I think we'll eventually be in a phase where, you know, we're going to be making a lot of batteries, but eventually we'll be doing a lot of battery recycling, not having to mine for new batteries. One other item I had in mind. Before I do that, I'll just take a pause here, and if anybody has any questions you'd like to ask. Yes.
There's concern about battery fires. We speak to that today. Battery cars catch on fire more often than gas cars, or about the same?
No, really, they don't. And I mean, first of all, the battery fire, the car fires with gasoline engine are a lot more volatile. It's more explosive. And I think if you Google it, you can find facts and figures that show there's way more car fires with gasoline cars, and they're more intense and they accelerate a lot more rapidly than with an electric vehicle. Now, I will say this, electric vehicles are still rather new. The Chevy Bolt had a problem for a while with a spontaneous combustion issue, and it actually led to a recall. The Chevy Bolt had to replace all of the battery packs. So it's still the early days of the electric vehicle. We may still see some problems, but I think the figures will definitely show that there's far more gasoline car fires than electric car fires.
Do we have another question? So my question is there any research on like solar regenerating vehicles?
So right. So a number of the electric car manufacturers are trying to put solar panels on their roof. I'm not a big recommender of it because, think about a lot of times people are parking in garages or they're in shaded areas. And so if you have solar on the roof of your car, you'll want to be in somewhere where there's good sunlight at the proper angle. And the other thing is, it's really that amount of square footage of a solar panel is going to really be kind of like a trickle charge. It will augment your battery, but it's not likely that you'll be able to get enough power out of that to run your car on daily miles that you will be traveling, unless it's a super light car and you're hypermiling and you're using it as efficiently as possible. But it is a nice supplement for maybe some people. There's some car manufacturers that have been trying to do it.
Yeah, I've been seeing on the internet that areas like Los Angeles are developing all kinds of new single passenger electrical vehicles. And they're doing that because they determined that 90% of people who drive are just one person vehicle. Do you see a future for this vehicle?
Well, it's interesting you say that. I've been a dedicated fan of electric vehicles for a long time. There was one that was out there called the Tango. It was like one person wide car, and you could actually put your shoulders on both windows, stick it out the window of both sides, and then there'd be one passenger behind you. And there was a company in Ohio called Myers Motors that had a small little 2-passenger 3-wheeler. There's been a number of other ones out there, and probably the best known out there is the one called the Aptera. If you all are familiar with that, it's a very kind of strange looking vehicle, cool, futuristic, like the Tesla Cybertruck. It's a 2-seater, super light, and I think that might be one that does have a solar panel on the roof. So I can't tell you what the future of those will be. I don't know if we'll ever have be cutting our lanes in half and having double wide, two vehicles in one lane. I don't know. It's an interesting proposition, but it doesn't seem to be around the corner.
Do you have any other questions? Guys are helping me get my steps in today.
So I have kids, these electric cars may take you 5 to 8 years to pay off your initial investment. Is it still good to pass off to somebody else, or are we gonna have used cars because all the electric cars are?
Yeah, so is the brunt of your question saying that they're still pretty expensive these days? Is that what you're getting?
And the lifespan, like after 5 years, is it still gonna be a good car to drive? Is
Right.
it gonna be a battery
Well,
long enough to get you to work and home?
Yeah, so the big question is how long the battery's gonna last, and I think we're finding that they're like gonna last longer and longer. It looks like Tesla has a battery managed system where they have a battery coolant. It's ideal to keep the battery at a certain temperature, and so they tend to be lasting longer. Do you know, you're the Tesla owner too, right? Do you know about any thing about how long Tesla says their batteries should last? I mean, I have a 5-year-old Tesla.
I've seen 200,000 miles.
Yeah, I'm seeing more and more data that's saying these batteries, not what the early data said, but they're saying that they're lasting longer and longer. Okay, so maybe the jury's still out on it, but as far as the sticker price of the cars, Teslas have been coming as one example. Okay, Tesla has been lowering their prices significantly over the last year, and I'll give you an example. Right now, the Tesla Model 3 with the federal tax credit, you can get it for $31,500. Think about that. That's probably less than your average sedan today. $31,500 sticker price minus the $7,500 tax credit. The one that this gentleman has is a Tesla Model Y, the SUV version of the Model 3. That one now is $36,500. So I think we're going to find the prices continue to drop on electric vehicles as economies of scale get better and better, as battery management, battery supply chains build up better, and the Inflation Reduction Act has been a tremendous incentive for, number one, we're seeing electric car manufacturers moving their production to the US and Mexico, because it's included in North America, number one, and we're also seeing solar panel manufacturers come here because of the Inflation Reduction Act and battery manufacturers. So I predict, a lot of people predict over the next 5 years, economies of scale will kick in, these prices will continue to drop, the batteries will continue to sell.
Do we have any other follow-up questions?
One more comment is that the cost of maintenance, once you buy that car, is significantly less than the gasoline car. You're not paying for oil change, listening to notes and everything else that goes along with that. The maintenance on a normal car is about $600 a year, and on an electric car is $100 if you count in the cost of tires.
It's a lot less. But I would just say, so the cheapest electric car that I know about out there right now is a Chevy Bolt. And I think after the tax credit, you can actually get that for a little over $20,000. Now, Chevy is discontinuing the Chevy Bolt because they're coming out with an Equinox that will be electrified and will have a better battery system. But they're also talking about eventually bringing the Bolt back with a better battery too. So a lot of it remains to be seen, but the trend is definitely for electric vehicles going down in price.
With the cars, you have four wheels, and you would think they would turn those four wheels into generators. It's like the same with you're going through wind, and you would put portals in there that the wind could then create more electric. Why aren't they doing that with electric cars?
Well, so for instance, my electric car has a dual motor. Okay, so it has an electric motor in the front across the axle and one in the back. And as soon as I let off the accelerator, you can feel that car go, ooh, ooh, it slows down. And what's happening there is regenerative braking, not really regenerative braking, but regenerative coasting. And so those electric motors on both those axles are slowing the car down, and they're generating electricity. And that is part of the efficiency of the electric car. So really that is kind of happening. Does that answer your question?
No, because you
Oh.
still have the four wheels turning all the time whenever you're driving. Those four wheels could become four generators.
Well,
And so where you're talking about, yes, that when you slow down, it's generating some electric, it would be able to generate electric all the time while you're driving. And the same with wind. As you have the wind going past, you would be able to have portals where the wind would go through and it becomes a cone shape. That increases the velocity, which would make it where it could create more electricity. So it seems like they should be able to create an electric car that's going to produce enough electric that you don't have to go to a charging station all the time.
well, honestly, I think we might need a good discussion with a very good electrical engineer to help break that question down. Okay, so and again, when you're accelerating, you're using energy to make the car move faster. But as soon as you let off the accelerator in a Tesla and some other cars, that the motor slows it down and it's actually generating electricity. So maybe I don't understand your question, but I think that's about the best you can do.
When you go down a really long hill, you're making energy.
Yeah, you actually on some cars you will see more mileage appear on the car. And it's saying that you have actually generated like a mile or two worth of energy while you were coasting down that hill. But I don't know. That's the best explanation I can have. Maybe it might require a good electrical engineer to figure that one out.
Do we have any other questions? All right, thank you so much, Fred. We're going to be moving on to our final presentation, but thank you so much for coming all the way for us. All right.